on your calculator, there's this button called sine, cosine, and tangent. Do you guys see those buttons? If you have a different calculator, they'll still be on there. Sine, cosine, and tangent. Those are trig functions that we're going to be using this unit. Above them, we have sine inverse, cosine inverse, and tangent inverse. It's like to the power of -1. Do you guys see those? We're going to be using those also this unit. So those help us find angle measures and side lengths on a right triangle when we don't have enough information to find it the way that we've learned in the past. So like we know Pythagorean Theorem, right? That allows us to find a side length as long as we have two side lengths. Now we're going to give you a little bit less information. We're going to be able to find side lengths and angle measures using that. So you will need this calculator during this unit, okay? Or a calculator. Preferably something other than your cell phone, right? Okay. So, Pythagorean Theorem. This is more of like a little review than anything. A right triangle. So basics of a right triangle. This is a right triangle, the triangle with one right angle. The legs of the right triangle are adjacent to the right angle. What does that mean to be adjacent? Yeah, next to. So they form that right angle. The hypotenuse of the triangle is blank of the right angle, is across from, and then I took out the word of, the right angle. Here's a right triangle. The only side that matters is the C side. Which one is the C? The hypotenuse, the one across from the 90 degree. A and B can be interchanged, so it does not matter which one's A and which one's B. But Pythagorean theorem states what? There you go. A squared plus B squared equals C squared. So if I square the two legs and add them, that should equal the square of the hypotenuse. We have what's called common Pythagorean triples. So these are triples. These are good to somewhat memorize. Like, I don't expect you to know all the triples. What I do expect you to remember is a couple of them. Because what will happen is on the ACT, if they give you a, like 25% of the ACT is going to be geometry concepts, okay? If they give you a question on the ACT that has to deal with a right triangle, 95% of the time they are going to give you a Pythagorean triple. So if you remember that Pythagorean triple, you are minimizing the amount of time that you're going to have to spend doing math on that problem, as long as you can remember that automatically. Does that make sense? 3, 4, 5 is a triple. What that means is that 3 and 4 are my A and B side, and 5 is my C side. It's my hypotenuse. What is 3 squared? What's 4 squared? And what's 5 squared? So does 9 plus 16 equal 25? So what this means is a 3, 4, 5 triangle is a right triangle lengths that work, okay? Then, as long as you know that 3, 4, 5 is a triple, you can multiply it by 2. We get a 6, 8, 10. Those are also 3 lengths on a right triangle that would work to make a right triangle. You can multiply it by 3 and get 9, 12, 15. Okay? So these are just multiples of the 3, 4, 5 triangle. Does that make sense what I'm saying on a 3, 4, 5 triangle, what it is and how that works? Okay. The next one to remember would be a 5, 12, 13. So these are commonly used triples that are whole numbers that work. When I square 5, when I square 12 and add them, I get the square of 13. So that would be like 5, 12, 13. That works. But then if I multiply it by 2, that also works. If I multiply it by 3, if I multiply it by 10, it doesn't matter what I multiply it by, it will also work with whole numbers. So 3, 4, 5, 5, 12, 15, 8, 15, 17, and 7, 24, 25. Those are all my main triples. If you can remember those 4, you are golden. I honestly probably remember this one and this one the most. Those are going to be your most commonly used. And really, the 3, 4, 5, and 6, 8, 10 are used probably 75% of the time. Okay, so what I want for you to do right now is I want for you to try to try to answer number 1 and then answer number 2. Someone remind me, how do you find area of a triangle? Base times height, what? Yep, 1/2 of base and times height. Or another way to say that right is base times height divided by 2. Same thing. So try number 1 and number 2. Okay, which one do you have to find first? I have to find y first because I have 2 of the side lengths for y. For x, I only have 1 side length. So how did you solve for y? What did you do? Thank you. This is y squared plus 81 equals 121, is that right? And then we subtract 81 from both sides. Y squared equals 40, is that right? Square root, square root. If you notice in the directions, it says simplest form. Do they want a decimal or what do they want? A what? Say it louder. Kind of, an integer. They want you to reduce this, like what we were just doing. So, that's where what we were just doing comes into play. So 20 times 2, 4 times 5, bring down the 2. 2 times 2, bring down the 5, bring down the 2. I have a pair of 2's. So this y is equal to 2 square roots of 10. Okay? Now, to find x, what am I going to do now to find x? Someone new. Yeah.
3 squared plus 40, because we already know y squared is 40 equals
Oh, good.
x squared.
Yep. We would take 2 square roots of 10 and square it, but we already know, like he said, that should give us back that 40, right, that we took the square root of. What is 3 squared? So that's 49. What's the square root of 49? So x equals 7. Okay? So let's find the area of this compound figure. Base times height divided by 2. So on this figure, on the first triangle, what is your base and what's your height? Nine and what? Did you say 1? Oh, y. What's my value for y? Yep. All that divided by 2. To that, I'm going to add my area of this guy. How am I going to find the area of that guy? Awesome. Okay, what's 9 times 2? What's 18 divided by 2? So that's really 9 square roots of 10 plus, what's 3 times 2 divided by 2, guys? That's 3 square roots of 10. Add those two things together and what do I get? 12 square roots of 10. All concepts we just talked about in that mini radicals unit, right? So that is the area. So we're going to say units squared of some sort. All right, next page. Yes. Because the formula for area of a triangle is just base times height divided by 2. Go ahead and do number 3, A, B, and C. Okay, on A, it would be x squared plus, what's the square root of 7 squared? Yep, and what's the square root of 19 squared? Yep, and so I'm going to subtract 7 from both sides, so I get x squared equals 12, and then I'm going to square root. Break this down into 3 times 4. 4 breaks down to 2 times 2, pair of 2's. So I have 2 square roots of 3 equals x. Any questions on that one? Okay, next one. 24 squared plus 10 squared equals x squared. Is this a Pythagorean triple by any chance? Oh, it is. Which Pythagorean triple is it? Yep, so the third side would be what? 26 equals x. So if you knew that, you had no math that you would have had to do on that one, right? Next one, this is x, and this is 8 square roots of 2. So x squared plus x squared equals, what is 8 square roots of 2 squared? Yes. So what you actually have here is you have 2 sets of x squared equals 128, right? So how do you get x squared by itself? Divide by 2. So I actually get x squared equals 64. Square root both sides, and what's x going to equal? There we go. Find the area of each figure. So we need to, on this one, we're going to have to find this height. And then we can do base times height divide by 2, right? So here is a right triangle with 4 squared plus x squared equals 12 squared. Four squared is 16 plus x squared equals 144. Is that right? What's 144 minus 16, guys? Square root, square root. I think we have to break that down into what? Isn't it 64 and 2? Is that right? What's the square root of 64, guys? 8. So this actually breaks down into 8 square roots of 2. So x equals 8 square roots of 2. But we're not done with that problem, right? To find area of that triangle, I do base. Be careful. What is my base of this figure? It is 8. Very good. All the way across. 8 times 8 square roots of 2, all that divided by 2. Base times height divided by 2. What's 8 times 8 divided by 2? 32 square roots of 2 units squared. Who remembers the formula for area of a trapezoid? I think it's... Yeah, no, you're right. It's base... I think it's base plus... What's my base 2? I divide that by 2, and then I multiply by my height, and my height in this situation is what? 14. What's 20 plus 11? What's half of 31? 15.5 times 14 is how much? Bless you. That is inches squared in this case. Okay, here we have what looks like a rectangle and then a triangle, right? Guys, what's my distance from here to here? It's 10. Because from here to here it says it's 3, right? Okay. This is a rectangle. So the rectangle, how do you find area of a rectangle? Just base times height. What is your base and your height of that rectangle? So it'd just be 3 times 4, which is 12. But then we have a triangle there. What's your base and your height of that triangle? 10 and 4. So 10 times 4 divided by 2. How much is that? 20. Now what do I need to do? Yep, add them. So I get 32. What are my units on this guy? Squared, right? Because we're talking about area. Beautiful. Good job, guys. Okay. Homework. In Schoology, I've added 3 homework assignments. Just do 7.1. And then do 7.1 practice C. Okay? You got 18 minutes of class left that you can use this time to do practice C and or the Schoology homework, whichever one you want to start with.